say that you were asked to find the slope of the line y equals to 2x plus 1. I know that some of you guys remember some stuff about linear equations. You might be able to jump right at the answer. But try and think back at the first time you were given this equation or something similar and you were asked to find the slope of the line. So if we're going to build on what we've learned about finding the slope of a line using the formula, for instance, then we'd need to find some ordered pairs, right? So the first thing we'd like to do is take our equation, y equals to 2x plus 1, and create a table of solutions. So x, y, and so x, y equals to 2x plus 1. So plug in some values for x and figure out the resulting value of y. So for instance, when x is 0, 0 is always a good one to try. Then y equals to 2 times 0 plus 1. So that means that y is going to turn out to be 1. And so we'd have a nice ordered pair of 0, 1. Right? Or when x is 1, then we'd have y equals to 2 times 1 plus 1, which means that y is going to be equal to 2 plus 1 or 3. So we'd have the nice ordered pair of 1, 3. Let's do maybe one more. When x is 2, then y equals to 2 times 2 plus 1. So that'll be 4 plus 1 is 5. Y equals to 5. So we get the points 2, 5. And so we can keep going and find many other points, right? As many other points as you want, you can find. You don't always have to stick to whole numbers, but we get the choice, we get the freedom to choose anything we want. So why not pick something that's, easy and straightforward? Okay, so now once we have all these ordered pairs, then we can choose any two of them and plug them into our formula. So our formula for slope is slope equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right? Where this is where one of the points is x1, y2, and the other point is x2, x1, y1, and x2, y2. Okay, so say for instance we chose these 2 points and we wanted to find the slope, then we could label them as 1, 3 and say that this is x1, this is y1, and then use the other point, which is 2, 5 as x sub 2 and y sub 2. So then our formula for the slope would end up being 5 minus 3 divided by 2 minus 1, which is equal to 2 over 1 or just 2. So we found the slope. We could have also used, say, another pair of points. How about the first one and the last one? Right? It doesn't have to be just these 2 points. We could also have used 0, 1 and 2, 5. And so our formula in that case would have been 5 minus 1 divided by 2 minus 0, or 4 divided by 2, or just 2 again. So we get the same answer no matter which 2 points we choose. Everyone's with me? Good. Okay, of course you could have also used the formula in the other way. Instead of doing 5 minus 1 and 2 minus 0, you could have done 1 minus 5 and 0 minus 2, and it still gives you the same answer. Okay, so we can present our solutions in a table like this, or we can graph them, and if we graph all of these 3 points and maybe some other points, we would find that they form to create a nice line, such as that one right there. And then we can also count squares to find the slope. So we can find 2 points on the line, think about the triangle underneath, and then count squares, rise over run. So as you can see, there's always 2 squares, 1, depending on a variety of choices that you make about the 2 points. Right? All those triangles have the same slope of 2 squares over 1 square, 2 over 1, 2 over 1, so the slope is 2. You can also think of a bigger square. It doesn't have to be 2 points right next to each other. Like if, for example, we looked at the point 0, 1 and 2, 5, and we think about that larger triangle that's formed underneath there, we can still count squares, and we would count 1, 2, 3, 4, 4 squares divided by 2. So 4 over 2 is still 2. or the last 2 points, the first one and the very last one, 0, 1 and 3, 7. Think about that giant triangle underneath. Count squares, and we would end up with 1, 2, 3, 4, 5, 6 squares in the vertical, the rise, and 3 squares in this direction. 6 over 3 is still 2. So no matter how you choose, which 2 points you choose, the slope always boils down to 2. Good? Any questions about that? No? 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 Okay. So, for a linear equation of the form y equals mx plus b, the m is the slope of the line. Okay, that's always true. If we can get a linear equation and algebraically, well, I shouldn't say that, all linear equations, with only one exception, can be written in this form. The only exception is vertical lines, right? Okay, so except for vertical lines, all other equations of a line can be written in the form y equals mx plus b, where m is the slope of the line. M and b are representative of real value numbers. So for instance, if we were asked this, are the lines y equals to 5 6's x plus 3 and 12y minus 10x equal to 5 parallel, perpendicular, or neither? So in order to be able to answer that, we need to find the slopes of both of these equations and then compare them. We know that 2 lines are parallel if their slopes are the same slope, and 2 different lines are perpendicular if their slopes are reciprocals, and also one more condition, one's positive, one's negative, right? Opposite signed reciprocals. And then the other thing I like to think about is that when you multiply the two slopes of parallel lines, they multiply to give you an answer of? -1. -1. Good. Okay, so what is the slope of the first one?
5 over 6.
Easy. So we have y equals to 5 over 6 x plus 3. This fits the form y equals to mx plus b, where this is the m and this is the b, right? It fits that form. So just by looking at it, I don't really have to do any work. This is the slope. So the slope of this first line is 5 over 6. Good? Questions, questions, questions? No? No? Okay, what about the second one? We got 12y minus 10x equals to 5. We generally can't just look at that one and know the slope the way we did with the other one. So we're going to have to do a little bit of algebra to manipulate this to make it fit this form. Y equals some number times x plus some other number. And when I make it fit that form, I know that the number in front of the x is the slope. Okay? So the first thing I'm going to do is move the 10x over to the other side. So I'm going to add 10x to both sides. Plus 10x plus 10x. Right? Maintaining that balance, moving that equal sign underneath. I'll get 10x plus 5 on that side and 12y on this side. Right? These two cancel out. And then I divide everything by 12. So y equals to 10x plus 5. Divide this side by 12. There's 12. There we go. Okay. And then finally we can reduce it a little bit, since 5 over 12 reduces to 5, 6x plus 5 over 12. This fits the form y equals to mx plus b, where this is the m and this is the b. So again, we've been able to take the original equation and manipulate it down to fit the form y equals mx plus b. So that means that the slope of this one is also equal to 5 over 6. And because this slope is the exact same as this slope, now I've proven that these two lines are parallel. These are two parallel lines. Good? Kind of a silly little thing, but just make sure this number is different from that number. Because if they were the same number, they have the same slope, and this number is the same, well, that means you really have the same line. Right? So we're talking about two different lines. Two different lines have to be parallel, otherwise you just have one single line. So just make sure that this number is actually different from that number, so you have two different equations. Sometimes they trick you where you start off thinking that they're two different lines, but when you do some algebra and simplify it, it turns out it's just the same equation, just one line. Okay, so two different lines have the same slope, but they have a different y-intercept. Then you know that they're two parallel lines. Okay, we'll work on graphing them on a calculator next week. I know many of you still don't have one, but you will soon. For a line y equals mx plus b, if the run is 1, then the rise of the slope is m. So, what are they saying? If I give you an equation that already has a fraction in there, well, there is the slope. Looks like that, right? And we can always write it into rise over run form, right? This is the rise, this is the run, like that. It's already a fraction, rise over run. So if I wanted to graph it and think about that triangle that it forms, I know it's going to be 6 squares in the horizontal and 5 squares in the vertical, rise over run. Okay, but the question often becomes, well, what happens if it's not a fraction? What do we do there? Well, this is simply letting you know that you can turn any number into a fraction by putting a little 1 in the denominator, and then in that case, the 1 is the run. So, for instance, if instead of dealing with this, okay, here is the equation, there is the slope, rise over run, there it goes like that. If we had a different equation that looked like this, y equals to 3.2x plus 7, right? That still fits the form y equals mx plus b, where that's the m, of course that's the b. So the slope is equal to 3.2. That's true. But then what we could do is a very simple algebra trick. We can just turn this into 3.2 over 1, right? And then in that case, again, this becomes the rise, and this becomes the run. So when we graph it, the horizontal change is just going to be 1 unit, and the rise is the whatever value you have there, right? So it's just a simple little algebraic trick to be able to convert any number into a fraction, and then when we graph them, you'll see that this becomes really useful to be able to sketch the lines using the slope. Good? Any questions? No? 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 Okay. So notice that if we graph them this way, then if we put a 1 there, the horizontal is always positive 1, and then the vertical is either positive if this is positive, so it's like the first picture there, or if this is negative, then it'll go down, and so we'll get the second one graph there. Remember that if a little stick person's walking on the line, the way we read from left to right, if the little stick person is going up that line, it's a positive slope, right? And if that little stick person is going down, then it's a negative slope. Good, good, good. Okay. The other important value here is the b. So for a linear equation of the form y equals mx plus b, the y-intercept is 0, comma b. So quick refresher. Remember that if we have a coordinate grid system this way with the variables x and y that way, then if a line did something like that, for instance, then we would say that that point right there is the y-intercept point. Okay, and what do we know about that point? Well, it's got to be an ordered pair, so it's got to be, 2 ordered pairs that way. And I know that the first value better be a 0, right? This must be x equals to 0, because that's the only way it could stay on the y-axis for the first entry to be a 0. Okay, so whenever you're given an equation, like let's say I give you y equals to 3x plus 2, and I want to find the y-intercept, what we do is we set x equal to 0 and solve for y. Well, if that's a 0 in there, y equals to 3 times 0 plus 2, then y equals to 2. Right? If we set x equal to 0, then we get that. So the ordered pair is 0, comma 2. Okay, well, if an equation is given in this form, then it just becomes really easy to figure out that that number right there has to be the y-intercept, 0, comma that number. So in general, whenever you're dealing with something like this, if we have y equals mx plus b, then if I type in a 0 for there, y equals m times 0 plus b, then this term will completely disappear. 0 times anything is 0, and so we'll end up with just y equals to b. Right? This is if we set x equal to 0. And so 0, comma b is the y-intercept. Any questions? No? 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 Okay. So, If an equation is of the form y equals mx plus b, we say that it's in the slope-intercept form of a linear equation. The slope, because of the m, that the m is the slope, and 0 comma b is the y-intercept, so we say that this is the slope-intercept form of a linear equation. If we were given this equation, y equals to 3x minus 1, it fits the slope-intercept form of a linear equation, right? Where the m is 3, and the y-intercept is 0, negative 1, right? So remember, y-intercept is a point on the graph. We need an ordered pair, so don't just say that the answer is negative 1. It's 0 comma negative 1. Okay, so now if we have those two pieces of information, which we can get relatively easily from just looking at our equation, we can use those two pieces of information to be able to sketch the graph of this line on a rectangular grid, right? We can do that by, first of all, graphing the one point we definitely know is on the line, 0 comma negative 1 in this case, and then using the fact that we know that the slope is equal to 3 and creating that triangle underneath the line to be able to find another point. Good? Make sense? For instance, let's go back to the first one we ran into back here. In this case, we were originally given the formula y equals to 2x plus 1. Y equals to 2x plus 1, right? And then we found some ordered pairs. So we found that 0 comma 1 and 1 comma 3 and 2 comma 5. They were all solutions to this equation. Then we graphed them. So we got this thing that looks like this, and we got a line that looks like that. And we had the point 0 comma 1 and the point 1 comma 3. And another point over there, 2 comma 5, something like that. Okay, so we had the points originally, and then we wanted to find the slope. We were asked to find the slope. So once you have some points on the line, we can think about this triangle that's formed underneath it. Right, and we can count squares. And so in this case, we were able to count that from here to there, we went 1 square that way, and then we went up by 2 squares, so this way to this way was 2 squares, so we were able to tell that the slope was 2 over 1. Right? So here we can tell that the slope is equal to 2 over 1. So we were given the points, or we were able to find the points, and we wanted to find the slope, so we counted squares. Now we're going to use this point and the fact that we have this triangle to find the other point that's missing. Got it? So we're going to start drawing this. And then we're going to draw this triangle, and it'll lead us to the other point that we're looking for so that we can sketch the line. Does that make sense? Good, good, good. Okay, so back to this guy. So now we're back to this guy. So now in our case, we have y equals to 3x minus 1. Y equals to 3x minus 1, and because it fits the slope-intercept form of an equation, y equals mx plus b, the slope-intercept form of a linear equation, I know the slope is equal to 3. I can turn that into a fraction by just putting a 3 over 1, and now I know that this is the rise and this is the run. Right? Okay, I also know that this must be the b, so I know that the y-intercept is equal to 0 comma negative 1. And now if I want to use these two pieces of information to sketch the graph, I first of all graph the one point I definitely know about. 0 comma negative 1 is definitely on my line. So 1, 2, 3, 4. So here is 0 comma negative 1 is right there. And now I can use this triangle underneath the line and the slope to be able to find the other point. So I know that if I was going to think about that triangle, I would go out 1 unit this way, and then 3 units up. So it'll be 1, 2, 3. So 3 units this way. And now, what point would this be? So I started off life at 0 on the x-axis, and I only went out 1 unit. So this point should be
1, 2.
1, 2. Okay, so 1 unit this way. I started x at a 0, and I went out 1 unit. And then I started out life at -1, and I went up by 3 units. So I end up at 2. So that's what that point is right there. Now all we have to do is connect them. And you got yourself a line. Oh, technical issues here. So now, close enough. Good? Any questions? Questions? We can do that again. We can find more points if we want to. How about if we go out 1 unit from here? So 1 unit this way. And then again we go up 3 units. So this has to be 3 units this way. And what point would that be then?
2, 5.
This guy right there would be 2, 5. Good. You can also use different triangles. It doesn't have to be 3 over 1. We can also use another equivalent triangle, another equivalent fraction by multiplying numerator and denominator by a constant. So for instance, if I multiplied it by 2, I would get like 6 over 2. That's another form of 3. So I can go out 2 units this way and 6 units up. Now we get to another point that's on the line. Good? Right, so here's an example. Yeah, question?
Yeah, we can go also like -2.
You can also go down. So be careful because when the denominator is positive, it means we go toward the right, right? And when the numerator is positive, then we go up. So if there is one negative in this, so if you're dealing with a slope that was, for instance, -3 over 2, then the negative only belongs to one of them. Don't apply them to both. So if you want to keep it in the numerator, that means that it will go down by 3 units, and the bottom one will go to the right by 2 units. Or you could do it the other way around, so we can keep it there, or we can keep it there if we want to. And now the denominator will go to the left, because it's negative, but the numerator will go up. So just be careful about the signs. So in our case, if we wanted to get tricky, what we could do is what? How do we throw a negative in there and make this still a positive 3? I could make it -3 over -1. Those cancel to give you a positive 3. In this case, so now I will go toward the left by 1 unit, but then I will also go down by 3 units, and I'll end up on the line as well. Right? So if you think about here, we go to the left by 1 unit, and then down by 3 units, you'll end up with this triangle over here. Kind of like this. Left by 1 unit, and then down by 3 units, minus and -3, and we still end up at another point on the line. Any other questions? No? Okay? So in general, we don't really get that complicated with it. It's just a really nice way to start off with an equation that fits the slope-intercept form of a linear equation, graph the y-intercept, that should be easy to do, and then turn that into a fraction, rise over run, and then you can get to one more point, connect those two, you have your line. Good? Questions? Okay. So, in general, so to sketch the graph of the linear equation, the form y equals mx plus b, find and plot the point 0, b, the y-intercept, and then use m equals to rise over run to find a second point, connect them. There is your approximation of the line. So, how about answering this? Working with general linear equations. Determine the slope and the y-intercept of the graph ax plus by equals to c, where a, b, and c are constants and b is non-zero. Okay, so find the slope of that one. What should we do? We have ax plus by equals to c, where a, b, and c are real numbers, or constants, where a, b, c are constants. Right? So this is just a generalization of like a whole family of potential questions that could look like this. For instance, it could be 5x plus 7y equals to 9, or 3x plus 2y equals to 13, or 3.2x plus 5.9y equals to negative 17.2, right? Dot, 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 dot. Right? What if I gave you like 20 of them that looked almost identical like this, and I asked you to find the slope of all of them? Well, instead of solving each one of them, it would take forever, why not solve it once in general like this one, and then you'd have a nice little formula that will give you the answer. Okay, so let's solve it in general for this one. So what should we do?
Isolate the y.
Isolate the y. We've got to make it fit into the slope-intercept form of a linear equation. So ax plus by equals to c. So let's move the ax to the other side. Minus ax minus ax. by equals to minus ax plus c. Divide everything by b. So y equals to negative ax plus c. And then we divide this side by b, divide that side by b. Well, actually, I guess I should have left it there and put it. Divide by b. B's cancel. So we get y equals to negative a over b x plus c over b. So what's the slope going to be?
Negative a over b.
Slope equals to negative a over b. And the y-intercept
C0.
equals to 0 comma c over b. Okay? So we found it in general. And now for part B, for instance, they said, well, what if we have this equation of 3x plus 7y equals to 5? 3x plus 7y equals to 5. Find the slope and the y-intercept. So again, why reinvent the wheel? We already solved it in general once. This fits that form. This is one of those, it belongs to the family of solutions to that one. This fits the form ax plus by equals to c, where the a is equal to 3, the b is equal to 7, and the c is equal to 5. Right? It fits that form. This is the a, this is the b, this is the c, and I already have the general answer. So the slope is going to be, it's going to be this guy, which is this guy, a over b, 3 over 7, but it's the opposite sign. And what about the y-intercept? 0 comma, and then it's c over b. c over b, 5 over 7. Right? So it just makes life easier if we can do it as a general solution once, get a nice formula, and then we get to repeat, solve various questions that look similar. Any questions?